Quantum physics, also known as quantum mechanics, is a fundamental branch of physics that deals with the behavior of matter and energy on extremely small scales, typically at the level of atoms, subatomic particles, and even smaller entities. It provides a mathematical framework for understanding the behavior of these entities, which often exhibit behaviors that are quite different from classical physics. Quantum physics, or quantum mechanics, emerged in the early 20th century as a revolutionary theory to describe the behavior of matter and energy on atomic and subatomic scales. In 1900, Max Planck introduced the concept of quantization to explain the spectral distribution of blackbody radiation. This marked the beginning of quantum theory. In 1905, Albert Einstein's explanation of the photoelectric effect provided further evidence for the quantization of energy, suggesting that light behaves as discrete packets of energy, called photons. Niels Bohr's model of the hydrogen atom, introduced in 1913, incorporated quantized energy levels for electrons, effectively explaining the atomic spectrum. In 1927, Werner Heisenberg formulated the uncertainty principle, which states that it is impossible to simultaneously know both the position and momentum of a particle with absolute certainty. In the same year, Erwin Schrödinger developed his famous wave equation, which describes the behavior of quantum systems using wave functions. The wave-particle duality concept, proposed by Louis de Broglie in 1924, suggests that particles like electrons and photons can exhibit both wave-like and particle-like characteristics. Quantum mechanics is mathematically described through the Dirac formalism and Schrödinger equation, allowing for precise predictions of particle behavior on the quantum level. In the 1930s, physicists like Albert Einstein, Boris Podolsky, and Nathan Rosen explored the concept of quantum entanglement, where the properties of two or more particles become correlated in such a way that the state of one is dependent on the state of the other, even when separated by large distances. Quantum field theory, developed in the mid-20th century, extends quantum mechanics to fields, describing fundamental forces and particles in a unified framework, as exemplified by the Standard Model in particle physics. These facts highlight key developments in the history of quantum physics, which has fundamentally reshaped our understanding of the physical world, leading to groundbreaking technologies like transistors, lasers, and quantum computing.